Hello and welcome also from my side. First of all, some branding. Well, I'm representing Napkin, which is a part of Neste Jacobs, which is an engineering company in Finland. I'm going to go through those first so you get a glimpse of what we are doing. And then in the end of the presentation, I'm going to show one way how we easily connect process analyzers to the OPC UA address space. Just to show what can be done and how it's done in the industry at the moment. So we had just the wastewater treatment, now we go for a different kind of process. Neste Jacobs is a global engineering company, nowadays owned fully by Neste, the oil company here in Finland. We have 1,300 engineers. There was earlier today someone that said that you don't need a control engineer anymore and you don't need a coder anymore to get things done. And so I was not that. It didn't sound that good from our side. But anyhow, we are number one in doing engineering in Finland. And we employ here in Finland roughly 900 people, 850 something. The rest are then abroad. What we do is that we do process industry. And of course our background is oil refining, petrochemical complexes, plastics, things like that. But we do also a lot of other things. So we are in the food industry. We are in biopharma, we are doing gas, we are doing biochemicals. So you see a lot of bio worlds there. So instead of doing from crude oil, we do from whatever. It could be rapeseed oil, palm oil, fish fats, so on. Whatever could be used as a feedstock product. So actually we are pretty big on that phase. So we are. For the biopharma, if you go and give blood, then probably our refinery has refined that blood to be a blood plasma when you need surgery. But then we do all refinery also. So it's a bit awkward sometimes. Our offices, of course, we are a Nordic-centered company, but we are also nowadays in Singapore, in Arab Emirates, in the Netherlands. But of course, the Nordics is our home ground, not only Finland. Our offering, or what we do, is from the Napkin perspective. But of course, you have the most fanciest plant you have done with the DXP way of working, the PNIDs and the engineering and planning. Based on that, or on top of those, we start doing. Look at the quality. We look at the production. We try to optimize that, get the most of what you have built, and that's the key thing with our Napkin Tools. You have the most fanciest plant, but also get the most profit out of it. That's in short what we do. We could look at it from a safety perspective. We could look at it from an energy and efficiency perspective. We can look at it from get more quality product out always and everything. And to do that, we have products that we have in 4 categories. They are what you see here: understand, improve, train, and decide. You can learn more about those. They're out in the booth. But to keep it short, decide is the first thing we do, even though it comes the last there on the slide. Let's figure out together, what do you need to do for your plant? Then when we know that and make a decision how to go forward, let's do the understand. And that's the whole thing for today. Collect the data, collect the information, do the analytics that you need to do, and do it the OPC UA way. Our products or tools, they talk OPC UA. I think this is almost my 10th time, so being around from the beginning of the OPC and OPC UA. So Informer is one of our products that got certified It's a process historian. It got certified in May this year. And it was the first ever and the fastest certification of an historian, according to the test lab. So still we are number one in that field. We do, of course, automation. We do the safety. That's the first and main thing in all refinery or in petrochemicals. Safety first and cybersecurity first. Then you can start moving information back and forth, as we saw in the previous slide, previous presentation. Moving set points back from the cloud. It might feel a bit hard for me to do if you go to a petrochemical plant. But the day will come when that happens. And we do analytics, which means that, of course, it's not just data mining and getting a lot of data and look at things. But instead, the main thing is that we have process knowledge in specific process industry segments. We put that knowledge in the analytics and give that, based on the information that we can dig out, we can do real magic for the customer for those specific segments. So it's not a common tool to do for whatever data you have. Instead, we have targeted for our segment of work. Then going to some basics. If you want to get the information from a plant and utilize it, then of course you need to, of course, OPC UA gives the best ever way to do it. You have a structured way to do it, you have a cybersecure way to do it, and you can add the semantics easily, and you should use it. And that will enable then that you can get a transparent and good view into what's happening in the plant. You need to get the analytics to move that dumb data, because everything that you pull out, you should consider it to be wrong until you have proven it's right. Then you can make real wisdom out of that. It was one study not in Finland but in Sweden early this year that they have pulled out from a big process plant all the information they could get. It was a huge chunk of data. And after a long evaluation period, they figured out that only 5% of that information that came from the sensor you could use for decision making. To think of that. You had the best ever plant instrumented, and you get a lot of data in, but only 5% is something that you can use. And that's also in other findings. We are talking about less than 10 usually. So how should I run the plant? Which are the right set points and so on? That's the wisdom. That's the thing that we need to look out for. And then you can start optimizing and do the most of your production. So that's the whole thing that we are doing with our tools. That's my backyard. That's the Kilpilahti refinery, the Neste Kilpilahti refinery. So that's our small manufacturing site that we can play around with in that sense. So you have all kind of needs, and you have all kind of tools that you need to bring in there for different kinds of people, different kinds of setups. And to drill down to a specific of the analyzers, the lab people there, for instance, they're in the white coats, they want to have information. They are not the automation guys. They are not the ones that are on the process side. They want to have the real information, what's really happening. Let's skip this one, but have this one instead. Of course, we have already today have a lot of talks about the different ways of handling data, different IT, OT, I could introduce one more way of thinking about it. You have this kind of industrial ICT there in between that do both. You have those that are plain automation, plain OT, and then you have those that really do the IT. But then there's a ever-growing middle section of systems that do always both. So it's not a distinct way of saying that you only have IT or OT, but you have from my perspective and what I've seen, this orange one is just growing, 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 and in some point it will eat up all the rest. And with OPC UA, you actually are doing it all the time. If you have try to explain that we have seen also earlier today about what are the systems, what are the levels of actual tools and things that happens in an industry. At any normal chemical process plant, you have these kind of setup. You have the ERP, of course. That's nice. Then you have the instrumentation automation. In between, you have something that might be connected or then are separate islands. Usually you don't have those when you go somewhere. For instance, the analyzers, they are a totally own separate network with no connection to anything. They are not in the DCS, they are not in the automation network for real, they are not either in the office network. They are somewhere in there between. What you do is that you only take down from the analyzers those signals that you really need and pull a cable between the analyzer and the thing that needs it. So you don't really get that information flowing. To get it a more worse picture is that, of course, you have these main things, but then you have a lot of other analyzing, you have a reporting, you have needs. And all these needs this information that you get from everything. So our way of seeing is that the orange one that we saw on the previous slide will be some kind of data highway. And OPC UA enabled data highway. Then we have these companion specs like analyzer device integration that then enrich the whole data model that you have there in the OPC UA. You can easily then add things with their own language to this data highway. And that's what I'm going to show you soon. So, an analyzer, what's that? Yeah, that's something that measures quality in any product stream. So, for instance, if you take an oil refinery, you could analyze to see that is my octane correct in the product. If I take some milk product, then I want to probably look for something totally different. So, but anyhow, quality parameters that say that if this is valid to sell or not. And to also tell if that really is a valuable product that we are doing. Two ways to do it. Either you put a milliamp signal, you pull the cable between the analyzer that does the work and usually the operator panel who wants to look at it. It means that you only take the one that you need for operations, for operating the plant, nothing else. But if you use get a vendor that has OPC UA with or without the ADI, the analyzer device integration, then you get a lot more. OPC UA itself enables that you can easily connect towards the data and get that flowing. But if you have the device integration on top, then you don't need to know really for real what is the real type of that analyzer. If I have several on the site, there might be 100 of those. So the ones that are then again the white coats there in the laboratory, they don't need to know that I need to look at that specific tag of that analyzer to get that information. It generalizes the information in one way and one view. You can do without it, but put it on. So something like this. There's a picture up there, is analyzers. And in this case, just to get illustrated also another thing, they're probably not in the same place. There might be a kilometer between. It might be a long and hard journey to pull the cable. In this case, what I'm illustrating, it's a smaller plant, close by operations. So this is like a worst case that we could see. But anyhow, if the rest of the network is okay, just browse up it and connect to it. And you could get a lot of information. So instead of getting that one single information point, this specific analyzer in one plant, it measures actually 37 different components of the stream. And every stream has 5 different, so I have done wrong math. Sorry for that. But anyhow, a lot of information ready to be analyzed, ready to be reused for anyone that needs it. These 2 slides may be a bit lame, but with UA it's just this easy. It's the tool of today. So it's there, it works. And actually this is what you get out of it. So, oh yeah, wow, nice. But anyhow, this is something we have had today a lot of about companion specification, a lot of the OPC UA collaboration. This is one of the first ones that were done several years ago. This is actually how it really works, and also for the rest of the companion specs that are ongoing, all the collaborations with the different vendors, it will actually be like this then. This is the future, how it will go. You don't sit and do cross-reference of getting data flowing from one system to another. You just point, click, and off you go. That's the power of what we have in the OPC UA at the moment. So, to summarize, data is the king. Probably so that you don't know what to do with the data at the moment, but there's someone cleverer than you out there somewhere that knows what to do with it. So just keep storing the information. That's the first thing. Don't decide in design or engineering phase what I will leave out. Try to get as much in as possible. All the analytics, all the semantics will do some magic sooner than later. Then, of course, cybersecurity. Don't forget that one. And then another thing is that as we get more information, we want to collect more information. If we do it the traditional way, it starts to get really, really expensive to make fiber wherever in a big plant. You can, just to get one single data point, you might need to pull 2 kilometers of fiber. And that's not cheap. So this way you can do a lot more. Oh yeah, and that's in short. Questions?
These questions. I have a question about the certification. You mentioned you had the first history on product, but I guess they didn't test the historical features yet.
No.
So that's still something that's missing, and
But that's something missing, and that's we are in trying to achieve, to get that reference architecture there.
Yeah, and we need to work maybe together to get those tests in place first, and so on. But yeah, I think Napkin is one of the most advanced OPC UI applications in the world that I know. You'll be working on it for a long time, and there's a lot of features that you've accomplished with it, and I think it's paid off very well because you have a very solid framework for building different applications on top of a framework that's really working, and OPC UI brings the functionality that enables you to work on a high level instead of concentrating on some small minor details in a technical aspect. The communication part between the modules is there.
That's true. That we have. This has been part of our main design principle since roughly 10 years ago. That this is the mainstream how to do it.
So today you can talk more about why you are using it instead of how you developed it.
We have a lot of successes and a lot of cases that really shows how it works. Okay. Next one.
Okay, thank you.